Hello, I'm Jack. Welcome to my channel, Practical Programming with Dr. Su. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create a 3D sphere surface chart with both color-mapped surface and a wireframe on the surface. In this video, I will use the same framework to create a parametric 3D torus surface. I will use the same framework to create a parametric 3D torus surface chart. Here, we will use the Git tool to clone the source code used in the last video. This is the download link at GitHub repository. From this link, you can download the source code used in the last video. Now start Visual Studio Code directly from Windows Start menu. Visual Studio, here's Visual Studio Code. This is a Visual Studio Code interface. Now let's start a new terminal window by pressing Ctrl+J key. Let's make a new directory called GPU46 and cd into this new directory GPU46. We then clone the source code used in the last video with the command git clone WebGPU45, then space period. This will place our source code in the current directory. So run this command. Okay, you can see all the source code is in the current directory. Now open this folder from Visual Studio Code. Open folder, code, GPU46. Okay, here source code used in the last video. Now open a new terminal window, Ctrl+J, and run the command npm install to recover the npm packages used in this project. Okay, finished. All the installed package stored in node modules directory. Before getting to the programming, we want to update WebGPU. Open package.json file. You can see here the WebGPU types version is 0.1.9. Now the new version 0.1.13 is available. So run the following command: npm install at WebGPU types at 0.1.13. So we specify the version to update it. You can see now the WebGPU types is 0.1.13. This is the latest version right now. I will show you how to update our example with this new WebGPU version when we discuss the programming code. In this video, we want to create a parametric 3D torus surface chart. The torus can be defined using a set of parametric equations as shown here. This is torus, this is the parametric equations. X equal to large R and small r, cosine V and cosine U. Y equals small r sine V. Z equal to R plus small r cosine V times sine U. You can see the large R is from center to this center, the torus, a radius. This small r is ring here, this is radius of this ring. The U a parameter is along this torus, and V is along this ring. So this UV as a parameter here. Now we need to add this parametric equation to the math func.ts file. open math.func.ts file from SRC folder. Here we need to add the Torus function. Here, the Torus function. This takes u, v, and center as input arguments. Here, the center let you specify the center of the torus surface. You can see here inside the x, y, z define, we fix the size of the torus. You can see we set large r equal to 1 and small r equal to 0.3. Now we can save this file and close it. Next, we need to make some changes to the index.html file. From dist folder, open this file. First, we change the 45 to 46 because this is a 46 video. And also, we need to change the sphere to the torus. The input parameter used here will be the same as those used in the last example. This drop-down menu lets you select different square images for our wireframe. You can see here we have 10 different square images to choose from. This is a drop-down selection for the color map that contains 11 color map names. Here we defined in the color map data.ts file. Now we can save this file. Now we need to make small changes to the chart.ts file. Due to that, we updated WebGPU to a new version, 0.1.13. Chart.ts file. Open this file. The most part of the code is the same as that used in the last example. We only need to change the here render path description. Now we have a load value field. This field will be removed from WebGPU, so they change the name to clear value. And also we need to add load option called clear. This load option can be clear or load. Here we choose the clear. Similarly, for the depth stencil attachment, we need to change the depth load value to depth clear value. And also we need to add depth load option to clear. Same thing here. Stencil load value, we need to change stencil clear value. And also we need to add stencil load option clear. Another place we need to make a change is, you can see here, and path. We need to change that to the and. So they change the name from and path to the and. Okay, that's all we need to do for the code updating. Now we can save this file and close it. Next, we need to make some changes to the main.ts file. From SRC folder, open main.ts file. First, here we introduce the create chart with texture from chart.ts file. Then, from surface data.ts file, introduce parametric surface data function. We then, from math.func.ts file, we need to change the sphere function to the torus. And next, we create a new function called create chart. This function takes several input arguments, including texture file, that lets you select different square image for creating the wireframe, and a color map name that allow you to specify color maps for our 3D surface. Inside these create chart methods, we call parametric surface data, but here the sphere we need to change it to torus. And also we need to change the data range here from 0 to 2 pi. And this division we called 40, and this changed to 15. The scale changed to 1.5, and the scale y parameter changed to 1.5. This parametric surface data function will generate vertex, normal, color map data, and UV data. We then call the create chart with texture function to create a torus surface chart with both color maps and wireframe. The rest code here is the same as that used in the last example. Here we define the default parameter. We use the white square as the default square image. The default color map name we set to the jet, and then call create a chart function to create a 3D torus surface chart with the default color map and wireframe. This part of the code allows user to create the torus surface chart with different color map and wireframe by selecting them from these two drop-down menus. Now we finish the modification to the min.ts file. We can save this file. Up to now, we have finished all the programming. We then can run the following command in the terminal window to bundle our TypeScript code in production mode. npm run prod. Okay, the bundle file is created successfully. Now we can click the Go Live link to open Chrome Canary to view our torus surface. Click this link. Here is our torus surface chart with default jet color map and wireframe displayed on this page. You can see our 3D surface chart looks very nice and pretty. Here we can change the color maps by select a different color map name. For example, here we click HSV and cool and go back jet. So you can select different color map here. We can also change the wireframe color. For example, we change it to red, green, and blue, and black. Of course, you cannot see the black. Black just looks like transparent here. Let's go back white. Previously, we have explained the reason for this issue. Use our shader code. Even though we cannot get a wireframe with a pure color except for the white, we still get a nice looking 3D surface chart with our square texture. Plus, we can easily change the line thickness of our wireframe by replacing our square image with different line thickness. If we create our wireframe using line primitives, the line thickness will be fixed to 1 pixel because currently WebGPU does not allow you to change the thickness of line primitives. Now we have completed this example. In next video, we will create a 3D parametric climb bottle surface chart. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.